Hey everybody, this is Larry. This is day one of April. Yay, day one of the new year, kind of. If you follow along, this is my 366 straight days of Leetcode Daily Challenge. And so this has been a full year for me. Yay, thanks for the follow, thanks for the likes and all that stuff. But if you're new here, then hit the like button, hit the subscribe button, join me on Discord. I tend to keep on going. And look, check it out. I have my Leetcode t-shirt for today to kind of celebrate the situation. Let me know what you think. Anyway, okay, let's go to today's problem. Palindrome linked list. Yeah, okay. Given a singly linked list node whose value are integers, determine whether the linked list forms a palindrome. Okay. So this seems pretty straightforward. N is 10,000, so you can't do anything n square. I mean, it's a linked list anyway, so you have to go through the list to check anything. So you cannot do better than linear time. So those are the first few things that I would check or think about. And yeah, and then the question is, there are a couple of ways to do it. The probably the most straightforward way is the most straightforward way, if I was doing a competitive thing, maybe just get the list, reverse it, and then see if it's right. If I'm trying to be a little bit smarter, then maybe I would try to figure out if I can. Can I do this in constant space, or at least log n space? I don't think so. Because I think if you do things recursively, because basically you can do push thing on a stack, either explicitly on with recursion, or sorry, with an actual stack, or implicitly with recursion. Either way, it's going to take linear time, so, to do that comparison. So I think I'm just going to. Yeah, I mean, I want to say this is, I don't know if this is cheating a little bit as well, because what I wanted to do was just like implement an explicit stack. But then in that case, you just have a list and then you just compare them from beginning to the end. And at that, at that point, like, is it really different than just like going through the list and put it in an array and then just compare it to it backwards? No, that's exactly the same. So, so it's like, it's just like brute force, but in more steps. Let's do that though. Yeah, I don't know. The thing is that I mean, yeah, you can do in constant time, or sorry, constant space if you allow more than linear time. The thing is that there's no way to go backwards on a linked list. Obviously, if you have a doubly linked list, then this is trivial. But you have to be able to go. Yeah, and the only way to go backwards a little bit is to use a stack to emulate going backwards. And at that point, like I said, it's just like everything else. So yeah, so let's do that then. Let's just do it away, and then we'll see if there are other better solutions as well. So yeah, and this should be straightforward if we did land on this way, which is you just go for the linked list. So current node is equal to no, while current is not none. We go current is equal to current dot next at the end, but before that we want to append current dot value. Cool. And then at the very end, we just check to see if this is equal to the inverse of it. This is how I would write it for a contest, but this is slightly more inefficient because it generates a second list. If you want to be more efficient, you would have 2 pointers and then just walk it one at a time. Let's give it a submit. Let's see how that goes. Cool. Yeah. Looks good. Yeah. I think for me, I am curious whether there's a better solution. So let's go through the discussion. Let's see. Find the middle node, reverse the right part. Loop the what? Okay, I mean, I see what they're doing. Yeah, okay. I mean, I guess that is a case that I did not point out, which is that if you're willing to manipulate the linked list, then yes, you can do it in quote unquote constant time. But I'm also pretty sure that anytime if I gave you an input, if I gave you a linked list, be like, hey, is this a palindrome? And then I get an answer, but then my linked list is all messed up. I think I would not appreciate that. So with all that, so that being said, I don't count that as a good answer. But I would say in an interview, maybe bring that up just in case, or if they kind of hint at it, maybe you're like, oh yeah, you could do it in place if you manipulate the input. But again, that's like, that's a little bit silly. So basically what that algorithm is just going to the back and then point backwards, you find the middle of the node and then you point backwards so that you can kind of have 2 pointers going that way. But again, you manipulate the next, and then your linked list is crap now. And I mean, I guess you can also do it so that you change the linked list back. But I don't know. That just seems like that seems almost cheating, but maybe not. I don't know. Linked list farms are always a little bit weird in that way. But I feel like it's not in the for me, it's not in the spirit of the problem to do it that way. But yeah, but you can, and I guess like at the end it doesn't, at the end you still get the linked list back, and I guess it's not manipulated if you change it back at the end. But it also is probably not going to be faster than this kind of comparison because of the locality of your memory access and stuff like that. But again, these are things you could talk about with your interviewer. It's all about trade-off, I guess. So yeah, let me know what you think. This is a inferior simple problem. And there's a lot of weird stuff about it. One more thing that I forgot to show in the beginning is, oh, look, I got my Leetcode t-shirt. That's all I have. I don't know. Let me know what you think about today's problem. Hit the like button, hit the subscribe button, join me on Discord. And again, I'm going to do, Leetcode problems all month or year, maybe. I don't know. We'll see how life goes. But I'm going to try to do as much as you can. So hit the like button, hit the subscribe button, join me on Discord. And, about take care of yourself, take care of others, stay good, stay healthy, to good mental health, and I'll see you next time. Bye-bye.